Okay, pause the video, take a minute, read the question, see if you can figure it out. Alright, the question is, which of the following could be the average of the numbers in the list? What list? We got a list of 7 real numbers, not integers, not even numbers. There are no restrictions on these numbers. They can have weird decimals if they want. We got a list of 7 real numbers. The smallest one is 2. The biggest one is 20. The median is 6. And the number 3 occurs most often. So we actually know quite a bit about this list. So let's go ahead and make 7 slots in which we're going to put numbers. The middle number is the median, and we'll go ahead and put 6 right there. We got to put 2 down here, 20 up here, and if number 3 occurs most often in the list, it's got to occur twice. And in fact, it only occurs twice because there's only 2 spots for us to put the number 3. Now the question is, what are the possible averages that I can get using these last 2 numbers? Well, if you put all these numbers into the calculator and add it up, it comes out to 34. And 34 plus the mystery number plus the mystery number divided by 7 has to give us our average. What could the mystery numbers possibly be? Well, the mystery numbers can be anything between 6.01 and 6.02, let's say, and 19.88 and 19.97. So what I'm going to do now is I'm going to punch these 7 numbers into my calculator and see what their average is. And then I'm going to punch these 7 numbers into my calculator and see what their average is. And then I know that the average could be anything between those. Okay, so I did it, and if you average the larger numbers, it comes out to be 10.55. And if you average the smaller numbers, it comes out to be 6.5757. So that tells us that the average could be any of these 3 numbers. So just using this technique of estimating the biggest that the average could be and the smallest that the average could be, and then realizing that it can be anything in between because it's a list of real numbers, we see the average could be any of these 3 that are on the list. So 1, 2, and 3. Now, a lot of you are probably not happy with the imprecise method of saying, well, the average could be everything we want between 10.55 and 6.5757. You say, no, I want to actually make sure I can achieve the averages. So to do that, we're going to look at the formula sum equals average times the number of numbers. Okay? And we would like an average of 7, we'd like an average of 8.5, and we'd like an average of 10. And in each case, our number of numbers is 7. So that means we've got to get a sum of 49, we've got to get a sum of 59.5, and then we've got to get a sum of 70. Now the numbers that we have, 2, 3, 3, 6, and 20, already add up to 34. So in order to achieve a sum of 49, we've got to do 49 minus 34 and we have to have two numbers that add up to 15. Likewise, 59.5 minus 34 gives us 25.5. We've got to have two numbers that add up to 25.5. Finally, 70 minus 34 gives us 36. And we've got to have two numbers that add up to 36. Hopefully it's not too hard to say, okay, 7 and 8. Here we could have 12 and 13.5. And here we could have 17 and 19.